Okay, so we're going to solve each of these systems of equations using substitution, and then we'll check the answers. Notice when I say system of equations, what we're saying is we've got two equations. We're looking for the x and y value that solves both of the equations simultaneously. And these first three, notice what I'm going to circle here. These first three are very conveniently containing an equation that's already solved for one of the variables. They all three say y equals something. And that makes it really easy for us to be able to substitute in because we don't need to first solve for a variable. Not that it's horribly difficult, but this just makes it easier for us. So, okay, let's see what we're going to do here. I'm going to zoom in on these and we'll solve these out one at a time. Okay? So, we are going to write the equation that we're going to substitute y, oops, we're going to substitute y with 3x into the other equation. X plus y equals 8. And since we're substituting y, we will say x plus, and then we put parentheses, and y is equal to 3x, so we're writing 3x in there. And now when we simplify this, we get 4x is equal to 8. And if we write 4x divided by 4, the coefficient of the variable, equals 8 divided by 4. And we get x equals 2. So this is a part of our solution. Why is it only part of our solution? Because we actually need to now find y. And I'm going to use this equation, y equals 3x, to conveniently find y, because we now know what that x value is. That x value is 2. And so we say y equals 6. So now we've got a set of coordinates in x and y that is the solution set for this. And how am I going to write it? We'll write it right here in blue. We will say 2, comma, 6. The x coordinate is 2, the y coordinate is 6. Okay? But what we want to do is, because it says in the instructions, solve each system, sorry, let me zoom it out, solve each system using substitution, and then check your answer. So if we're going to check our answers, then we need to take the two original equations, x plus y equals 8, and y equals 3x, there they both are, and we're going to actually substitute those values in. So we say parentheses plus parentheses equals 8, parentheses equals 3 times parentheses. And what are we going to sub in there? We're going to substitute in 2 for x and 6 for y. And then, of course, when we solve them, we get 2 plus 6 is 8. 8 equals 8. That's true. Check. And 6 equals 3 times 2, which is 6. Check. Okay. So we've solved that problem by plugging in 3x for y, and then solving out for x, and then using that x value to find what y is. And then we have an ordered pair, and we proofed it. There. So that's how you do the first one. We're going to do the second one the same way. Hope that this is okay for you zooming in like this. I'll zoom back out, and you can see at the very end all the equations. So if you want to pause it at the end and just examine them all before the video ends, you're welcome to do that. So since this is the equation here that we have solved for the variable, y equals x plus 3, we're going to use the other equation, 2x plus 2y equals 38, and we're going to replace y in that equation with what it's equal to, x plus 3. The whole point of this is that we are taking an equation that is containing two variables, meaning we'll never be able to nail down one because if one changes, the other one changes. And we're turning it into an equation with just a single variable, in this case x, and that becomes solvable with a single equation. So 2x plus, and we distribute here, 2 times x is 2x. 2 times 3 is 6, equals 38. 4x plus 6 equals 38. And we're undoing order of operations, so the first thing we need to do is subtract that 6 away, and we get 4x equals 32. Moving down, we say, okay, then 4x divided by 4 equals 32 divided by 4, same thing to both sides, and we find that x is equal to 8. That is a partial solution because we don't yet know what y is. But we're going to find it out in a second. So now, let's zoom in. We're going to take that equation, y equals x plus 3, and we know that x equals 8. There it is at the bottom. Sorry if this makes you a little queasy. And we're going to say, okay, then y equals parentheses 8 plus 3, or y equals 11. Now we've got a set of coordinates. We have 8, 11 as our set of coordinates that solves this. And let me just zoom out for a minute so you can see what the math was there. But we're not done, because what we need to do is we need to draw an equals line, and we need to actually check both equations to see if they're true. So I'm going to write 2x plus 2y equals 8. And we're going to plug in 8 for x, 11 for y. To parentheses 8 for x plus 2 parentheses 11 for y. Did I copy that right? No, sorry, it should say 38. My mistake. 38. Okay. Solving it out, we get 16 plus 22 equals 38. And 16 plus 22 indeed is 38. Make sure you check it. I can do that mental math, but if you aren't sure, then you need to go that extra step and check it to be sure. Okay? And the next equation is y equals x plus 3. Y equals x plus 3. Substituting in, and I know that x was 8, what we found, and y was 11. And if we do this math, we get 11 equals 11. Check. So we've solved the system through substitution, and then we checked our answer by taking both equations and plugging it in. Remember, if you only check for one equation, you don't know whether it's a point somewhere else on the one line that isn't actually the point where the other line is crossing it. So remember, there's an infinite number of solutions for any given line. So the only way that you know that it's the solution to the system is to check both. Okay? So let's zoom in and do this last one. And we are going to take 3x plus 4y equals 7. And we're going to substitute in for y the expression that y is equal to, and that expression is x plus 3. You can see that we're going to need to distribute. So we get 3x plus 4 times x, 4x, 4 times 3, 12 equals 7, or 7x plus 12 equals 7. Subtract 12 from both sides, and we get 7x equals negative 5. I'm going to move this up. Next thing we need to do is divide by whatever the coefficient of the variable is. 7, and we get x is equal to negative 5 over 7. But Mr. Massey, it's a fraction. It must be wrong. False. We do not assume something's wrong because there's a fraction in it. You're not always going to get whole number answers, and get used to that fact. Okay? So I'm going to take my other equation. X plus 3 equals y. X plus 3 equals y. And we know what x equals, or we suspect we know. And that is negative 5/7. Okay, so this is negative 5/7, and this, if we calculate what 3 is equal to in terms of sevenths, we say how many sevenths equals 3? Well, what number when divided by 7 equals 3? And that's 21. All right, so then now that we have a common denominator, we can actually just do the subtraction. Here what we're dealing with is that we say we have this many sevenths, and we're adding this many sevenths to that amount. So really we're dealing with a thing called sevenths. It's a specific type of thing, the type of thing that it takes 7 of them to make 1. So that's all. And how many do we have on the first one? We have negative 5 plus 21. So we get how many sevenths left over? We get 16 sevenths is equal to y. And if we wanted to turn that into a mixed number, how many times does 7 go into 16? It goes in 2 times. 7 times 2 is 14. So if we took those 16 and took 14 away to make the 2 groups, we'd have 2 left. And what are they? They are sevenths. So those are our coordinates. And now I'm going to zoom back out here and say, okay, then let me write down the coordinates. We've got negative 5/7, comma, just a second, sorry, 2 and 2/7. Okay. And we do need to proof this. We need to just check and verify that that actually works out. So we're going to take our original equations, and we've got one of them is 3x plus 4y equals 7, and the other one is x plus 3 equals y. Okay? Excuse me. And let's zoom in one at a time and solve these in turn. So we've got 3 parentheses plus 4 parentheses equals 7. And what goes in those parentheses? Negative 5/7 for x, and 2 and 2/7 for y. And I'm going to just put these values in here while we're here. We've got negative 5/7 here, and 2 and 2/7 here. Okay? So let's solve these each in turn. 3 times negative 5/7 is negative 15/7, plus 4 times 2 is 8, and 4 times 2/7 is 8/7 equals 7. Okay? And although we could turn these all into sevenths, I'm not going to. What I'm going to do is I'm going to say, okay, we need here, we really need 15/7 to cancel out these negative 15/7. And I know that I can borrow 1 from here, and that then becomes 7. And I could add what is equivalent to 1. Remember, 7/7 is equal to 1. So I'm adding 7/7 onto the 8/7. So that gets another 7 for a total of 15/7. So now we've got negative 15/7 plus 7 and 15/7. And as you can see, this negative 15/7 and this positive 15/7, maybe I should have made that 1 a little bit better, are exact opposites and they cancel out. So we're left with just the 7. Okay? 7 equals 7. That works. And now over here, we've got negative 5/7 plus 3. And remember what we did here? We said, okay, 3 is equal to some number of sevenths. How many times this, well, what's 7 times 3 is 21, so we need 21/7 to equal 3. And this is 2 and 2/7. And now when we subtract, we get 16/7 equals 2 and 2/7. And then we're going to change what's on the left into a mixed number. 7 goes into 16 twice. That's 14. There's 2 left over. 2 and 2/7 equals 2 and 2/7. Check, that works. So we've done a proof for that one, and it works as well. These seem long, but remember I just did 3 problems altogether. You substitute it in, you find out what the value is for one of the variables, and then you use that value in the other equation. So you're left with just the remaining variable you're looking for, and you solve for that. Then you plug both in to both equations to make sure it works for both of them. And in that case, it does. So you can pause that and you can take a look at that as you need it. But that's all the math, and that's how you do it.